Hello everyone. In the previous set of videos, we have been discussing about performing classification tasks using OpenAI model and a couple of open source models. From this video, we are starting a new series where we are going to run a lot of experiments with the different set of models so that we can compare the accuracy, the latency, throughput, and other metrics related to the models. Let's get started. We are going to start our experiment with GPT-3.5 Turbo. But wait, why do we want to perform a classification task using an LLM? Can't we do it with a machine learning model? Yes, but there is a catch. To perform any supervised fine tuning, we need a concrete data set. And the data set that we have with us is 6 million articles which are untagged. Imagine you have to take 50,000 articles and humanly annotate these articles into respective categories. It takes a lot of time. Instead, we are going to leverage OpenAI models to perform this classification, and we are going to hold these classified articles as the ground truth, and we are going to train our machine learning models on top of it. The first thing is to install the required packages. So we are going to use datasets for downloading the Wikipedia dataset from Hugging Face, and we are going to use tick token to count the number of tokens that we are going to send it to GPT-3.5. It will be really helpful to perform a cost analysis of how much we are going to get billed for sending all these tokens into OpenAI. And we are going to use LangChain integration and make sure to install LangChain OpenAI as well to perform the integration with GPT-3.5 and other utilities as such. So I'm just importing all the packages, and I have loaded the data set. Okay, so the data set, as I mentioned, it contains a length of data set is, so the length of data set of train is around 6 million articles. um, Feel free to choose a bigger number for number of samples. Since it's a live demo, I'm just choosing the first 100 sample, but feel free to choose as many number you want. Imagine you want to classify 10K articles, then you just have to make this change where you set the number of samples to 10,000. So in this step, I'm just using the first paragraph for classification. All these things we have done in the previous set of videos. So the next item is to initialize our OpenAI environment. To do that, I'm using LastPass. Just put in your OpenAI token, paste it, and let's instantiate our LLM. Okay. Now, the next part is the output parser. When we perform classification, we are going to send in a prompt, and we are expecting the category as the output. To have the output efficiently in the same format, we are going to use JSON, and hence we are using the output parser, and we are going to use pydantic for this, so that whenever LLM outputs the category, we want to be it in a specific format. So here we can specify what class it is, and we are expecting a category which is a string field, right? And it's the description is category of the article. And if the LLM is not returning anything, then we are going to default it to others. So others is the category. But if the LLM is going to send it as an output, then we are going to keep that output as such, right? So this setup helps us to force the LLM output in a proper JSON fashion. And here is a template. So this is the prompt that we are going to use, and it's fairly straightforward prompt. We're just instructing LLM to perform classification. Here you can see your task is to assess the custom article and categorize the article into one of the following predefined categories. And here I have given almost 50 categories for the classification. It's a long list, we can see, right? And after this, we are going to instruct LLM to output this category in a JSON format. And since it's a prompt template, make sure you use double curly braces. If you use a single curly braces, it's more like a variable, right? So you have to use double curly braces in terms where you want to force it as a JSON output. And this is the output that we are expecting from the model, the category. And this is going to be the name of the category, right? Either geography or history or science or other category as such. So this is a prompt template. Let's print it. And here we are adding a couple of more instructions. Keep category name simple. Use only lowercase characters. And another important instruction that each article can be mapped to only one category. And we are sending in the article here, and we are expecting LLM to categorize the article, right? So let's, the next step, we have the prompt. Now we are going to run this cell. Basically, we are asking from the prompt, we are creating a prompt template, and we are using this setup of LLM chain where we are going to bind our prompt, the LLM. The prompt is the classification prompt, LLM is OpenAI LLM, and parser is nothing but the JSON output parser that we used. So we are going to bind all three things together and create a chain. So whenever you do chain.invoke of something, which is a article, it flows through this setup where it first goes to the prompt, and in this prompt, instead of article, this particular article will be placed, and it will go to the LLM, which is GPT 3.5, and LLM will give us a response, and we will take the response and parse it using JSON output parser. Before we perform the inference step from a cost estimation, remember, when you want to perform a cost estimation, you make sure to include your prompt, right? In our case, we are using a prompt. This is our prompt, right? All these tokens in the prompts will also get charged, right? So we are going to get charged for this as well, and hence I have created a separate variable called system prompt token count, which is nothing but the token count of our template, right? So we are going to take our template and we are going to multiply it with number of articles, right? So imagine we have around 10K articles, then we are going to send the same template 10K times, right? So since this is 100 articles, you can see 26,600 is the number. And apart from template, we also have our articles, original articles, and we are going to count the number of tokens of each and every article, which is nothing but 10 to 84, and put together the total number of tokens is 36,884. This is for 100 articles, right? So we are going to send 36K tokens for 100 articles, right? And here I've done a big estimation using for GPT 3.5, GPT-4, and GPT 4o. Here you can see it's $0.05. It's less because we are just doing 100 articles. Imagine you're doing the same for 10,000, and then the cost will be really heavy. The reason we chose GPT 3.5 is the same. One another point to note here is, in this step, we are considering the cost only for the input tokens. But if we move to pricing platform, right, let's go and see the pricing, GPT 3.5 Turbo. Here we can see the price is not only for the input token, it's also for the output tokens. This is a very big estimation because we are considering only the tokens that we are sending into the LLM. Whenever you send in a prompt, imagine you are taking an article, you are attaching it to a prompt, and you are sending it to OpenAI. You're going to get a response in a JSON format. The number of tokens that has been written by LLM, for those tokens, we are going to get charged. And the charges are $2 per million tokens. Keep in mind that we are going to be get charged for the output tokens as well. It is very crucial because in terms of classification, we are just expecting a simple string as an output. When you perform a task like summarization, each summary will be a paragraph or longer text, and the number of output tokens will be even more, right? And hence the charges will be drastically differing. Let's get to the final step. Final step is fairly simple, just one liner. In case you want to do only one article, it's just chain.invoke, you pass in the article. Since we are going to do it for 100 articles, for each article, I'm going to perform chain.invoke. I'm going to get the result. The result that we are going to get will be in a JSON format, right? And it will, I'm expecting it to be in this format, right? I'm just expecting it to have a category and the category name. Since we have used the JSON output parser, the result will already be a dictionary. So all I have to do is to just look for category in it. So let me run this for first few iterations, then we will know how exactly it is. You can see for the first article, it has already classified it as politics, and it's a dictionary with a key category. So all I'm doing is just looking for the key category, and whenever I find the category, I'm just inserting that respective category into the result. If in case I am not finding a category key, there was a case where LLM didn't respond with a valid output, I'm just appending an empty string. And in case there was a failure, I'm just appending it with a empty string. Let's wait for the completion. It's running. It's almost done. 97, 98, 99, 100. Let's just look at the results. It's just a series of list because we have appended everything as a list here. The result, right? We have parsed it, and here you can see there were a couple of exceptions where either the output wasn't the in the correct format, or maybe it could be a case where there was a failure. Let's quickly validate the results. So let's pick some random index, say articles of 2. Okay, it's about the alphabet A. Let's look at the result. Results of 2. Okay, the article has been correctly classified into linguistics. Let's try some other article. Okay, it's Greek mythology and it has been tagged to mythology. One more. Okay, it's tagged to history. Let's check another article. It's Aristotle, and yeah, the article is about Aristotle and it has been correctly classified to philosophy. So the results are good. I have published these results in the Hugging Face URL, which has been put in the description. We are going to discuss two important items from this experiment. Number one, as this is the first experiment, I wanted to keep it simple, and I have classified these articles in a sequential manner. In the live demo, we had 100 articles, and it took 1 minute for us to complete this classification task. Imagine we want to do this for 10K articles. It's going to take 100 minutes for us to complete. All these articles are independent. We can asynchronously process these articles, but OpenAI imposes a rate limit. For example, I'm in the tier 1 rate limit, and for GPT-3.5 Turbo, there are two parameters. One is request per minute, which is 3,500. That means we cannot send more than 3,500 requests within a minute. And we also need to make sure that we are not sending beyond 60,000 tokens per minute. TPM is tokens per minute, RPM is requests per minute. Okay. You need to make sure that the parameters are under control and we are not exceeding the threshold. Otherwise, we are not going to get the expected response. In the future experiments, we are going to change this code a little bit so that we can asynchronously send this request in a controlled fashion. The second important parameter that we need to keep in mind is the cost. Instead of 100 articles, imagine we are going to classify 10K articles. I have loaded the dataset. Now, let's move to the cost estimation part and let's see how many tokens are there in our prompt. So we have 266 tokens in our prompt. When we loaded 100 articles, it was 26K tokens. Now, since we have 10,000 articles, we have these many number of tokens being sent to OpenAI. We need to revisit this later because we don't have to send the system prompt again and again if we do a batching, which saves a lot of money for us. And another thing is the user prompt, which is nothing but our articles. Put together, this is the total number of tokens, and this is going to be the estimated cost of input tokens. And hence, it is important for us to perform these two steps. One is to asynchronously process these articles so that we get the results much faster. And number two is to tune our template and perform a batching mechanism in a way that it can be processed effectively with a lesser cost. I hope the video was helpful. hit the like button and subscribe to the channel. Thank you.